Once it is visible to you, please let me know. Once my screen is visible.
Yes, it's visible.
Okay, great. Thanks for confirming. Okay, so today we are going to learn about feature engineering. Yesterday we discussed about you know why feature engineering is important and what exactly is feature engineering in terms of machine learning and all. First, we will have the historical data. Then we have to do this feature engineering, right? So this feature engineering we will learn today, and also we are going to learn about how to divide this train and test, and what are the different types of algorithms, supervised and unsupervised, what are the difference between them. Up to here we will learn today, and tomorrow we will start about individual algorithms. Okay, yeah. And okay, so let me again explain you what is feature engineering. Yesterday I just given you a brief idea. Today I come up with really good notes of feature engineering, and also I presented in a nice way like why it is important, why and what are the different features are there. I mean different types are there. Everything I have provided, and how to choose, what are the strategy, what are the ways, step by step approach. Very important thing, approach. What is the best approach to select a feature to engineer? Everything I provided here. So let me go through one by one. So first of all, what is feature engineering in machine learning is feature engineering. Yes, it is a process of improving the data set to make machine learning models work better. Yesterday we discussed about small example, right? If you want to learn any subject, mathematics, let's say, it is a big task to arrange the proper data set for that, and also to organize that in a well way where it will help you to learn the concept easily. Correct. That is why we sometimes write running notes if you want to learn any subject while taking the session, or while attending the any session or class. We will take the running notes so that it will help us to understand that concept quickly, and will help to us to learn that concept quickly and effectively. So feature engineering, that is all feature engineering in real time, but in feature engineering in machine learning is also the same process. It's just that improving a data set to make machine learning models to work better. It involves what are the steps? Means it involves selection of some data, or transforming the data, and creating. Sometimes we have to create a new features also, and that help the model understand the patterns better, and also make very good predictions, accurate predictions. Why it is important means, yes, because it is very important, because raw data, I already told, raw data is often messy, right? It may have some missing values, irrelevant information, inconsistencies, and all. If we train the same model, if we train the model on the same type of messy data, it will not perform well. That is why feature engineering will help us to cleanse the data. As a part of this, we will remove errors, handling missing values and outliers, all some kinds of tasks we will do as a part of cleaning the data, transforming the data into useful formats, something like scaling, encoding to useful format, and also sometimes create new features according to the domain or according to the use case. That will definitely will help us to highlight important patterns. Okay. Then what are exactly features are? What are exactly features are means, features are something like a key characteristics or a properties of data that describes each record. I already told you with the help of data set, right? For example, uh, FEMA India data set don't have any columns. Okay, it don't have any columns. This is a data set. Okay, we know that this is a data set, and this data set, if you can see, there is a column name MPG cylinder. If I want to understand what exact 3609, you will definitely tell it belongs to weight, so it is the weight of the car. Correct? You are identifying the record based on the feature. Got it? Now let us come back to this point. Features are nothing but key characteristics or properties of data that describe each record. Okay. For example, in a data set of houses, features could be number of rooms, size of the room, and price of the room, or price of the house, location where exactly it is existing. These are all can considered as features that will help us to determine a particular record. Okay. What are the types of features in machine learning? Remember this point. We are only having four types of features. Either it can be numerical features or it can be categorical features. Categorical features means something like this: gender, male or female, shoe type, small, medium, large, such type of categories wise the data are text data. Text data, you know, right? Already words or phrases used as a data. Example, reviews, customer feedback, names, and all text data. Then the fourth one, time series data means date, data that assign that changes over the time. Time is a factor. Time is a column available. Example, stock prices, daily temperatures. These are all time-based ones. Now you go back to this one. If you observe, MPG is a numerical. Cylinder is also a numerical. This is also numerical. Numerical, 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 numerical. Origin is a categorical because we are having some categories. Here, name completely text data. Okay. In that way, we have to identify. We don't have any time data in this data set. So down the line, if we are dealing time series data analysis and all, we will going to learn. Okay. Okay. Why our features are very important? Because good features make machine learning models accurate. We already discussed. So we have to identify what are the good features are there. What features are really important. While bad features can mislead them. For example, let us consider small example. You are preparing for an examination. You are learning a subject. In that subject, if you don't know what are the units are required for the exam, let us say unit 1, unit 3, unit 5, unit 6, 4 units of textbook is really important for examination. But instead, you don't know the thing like you don't know the syllabus. You just read the textbook. You also read second unit. You read first unit, second unit, third unit, fourth unit. You missed 5 unit, fifth unit. Okay. So you directly go to the examination and then you identified that there is no question from the second unit since second unit is not a part of your syllabus. In that situation, the important feature was misled. The wrong feature you were learned. Definitely your accuracy will be less. If you know prior, only first unit, third unit, fourth unit, and fifth unit are a part of syllabus, then you could have learned those 4 units only. You will answer the most of the questions, then you will get good marks. If you consider these things, yes, features are really important for machine learning, making machine learning models to perform accurate results. Then feature selection versus feature engineering. There are two terms which always makes us confusion. First is feature selection. What is this feature selection? Is picking, selecting. Selecting is also called as picking. Picking the most important useful features and removing unwanted, unnecessary ones. In my just give an example. What are the important features means? The first unit, third unit, fourth unit, and fifth unit are very important. These are the selected features. Remaining features are not important. Second unit, sixth unit is not important. We can remove that. Okay, that is what feature selection. Then what is this feature engineering then? Feature engineering is creating new features or modifying the existing ones to highlight useful patterns. In the unit 1 again, you may not need entire unit 1. In the unit 1, you can prepare notes. You can prepare notes out of unit 1, what are really important, what are the concepts are really important. You will only consider that. You are modifying, right? You are selecting further. You are modifying or adding some more features, some more data. Okay, for example, in your textbook, there is only two lines only are there, but 2 lines are not enough to learn that subject or to pass that unit. So you will refer some sources like YouTube or some other research papers. You will add more data to the existing one, and then you will go for examination or you will go for preparation at least. For example, instead of using date of birth, so we can create a new feature age out of the date of birth. It is the best example. So we will have date of birth of the patients. Instead, we can calculate the date and then form a new column to the existing data set. Only important factor is date. We don't require date of birth. Correct. So these are the This is the best example we can say for feature engineering. We are engineering a feature. We are modifying or creating a new to highlight useful patterns. Okay. Now, feature engineering techniques, the best techniques, all I mentioned here. Please go through everything so that if you practice all these things, mostly you will, going to do feature engineering out of these particular things only. First thing is handling the missing data. First thing. Second thing is handling the categorical data. Third thing is feature selection. Fourth thing is polynomial feature, sorry, feature selection, and then creating polynomial features, and then feature selection. After that, variable transformation. Okay, these are the most important and widely used in feature engineering techniques. So I provided all these things. I will cover also most of the all the things I will cover. Don't worry. And also I will provide you the best practices so that it will help you whatever the domain or whatever the project that you are going to work on further. It will really helpful to do it in a better way. Okay, or also and also to do it very quickly. Okay, first thing is let us all discuss about handling the missing data. So you know how to read the data set, and these are the libraries that I'm using to do. Scikit-learn is a machine learning library developed by Google. So using that library, we can do these two steps. I will show you in this thing. We can do uh, yeah, yeah. So using scikit-learn, we can do this, and we can do this division. We can do this. We can do this. We can even do this. Okay, all these things we can do. So this part, feature engineering part and machine learning part, these two parts especially we can do. Feature engineering part, FE, and these are all machine learning part. We can do these two steps. Okay, feature engineering purpose we can use scikit-learn. Machine learning purpose also we can use scikit-learn. And evaluating like new data is also can be do, but not that much effective. So that's why I mean this is also possible with scikit-learn, but we are not going to cover using scikit-learn. So these two things especially we can do, feature engineering and machine learning part. Inside machine learning part again, dividing the data sets into train test and also choosing a machine learning algorithm, building a model and testing with I mean evaluating, validating with the test data. All these things effectively can be done using scikit-learn library. Okay. So scikit-learn library. So for pre-process or for feature engineering, these are the things I am using. Imputation and pre-processing. Inside pre-processing, one-hot encoder, label encoder standard. All these things I will explain. Feature selection, how to select the best features, and then linear model. So these things we are now learning. We are going to learn. Okay, how to use these functions to do feature engineering. Okay, first of all, let us read the data set. You know that how to read the data set. This is the data set that I'm using. So this is PIMA India dataset, very, very popular and widely used in healthcare dataset from so many years, from so many years, 6 years, 7 years. This is a standard dataset in healthcare. PIMA India means this is Indian dataset only, and it is from rural part of the India. So where they really, did like the diabetes based on the women data. This is all women data, collected all the data points from women. So that particular part of the country, their scientists or doctors identified diabetes is a quite common disease comes to women. They really wanted to do research. That is a that is good story. You can see PIMA India, PIMA India diabetes story. So the background, okay. So you can see PIMA India's Native America group in Arizona. Okay. So native in Arizona, okay, native Indians. There are native Americans, but there, I mean, maybe some Indian was there in Arizona. It is a very quite common, okay, quite common in their genetics. They really wanted to know what are the affecting factors, why those many people are having diabetes and all. So they collected the data. Here, if you see, our data set don't have any columns, but we know that the columns are okay. Just a second, somebody. joined. I will admit. Okay, what is your doubt, Preswell? Please.
Hey Shwant, sorry to bother, but so
Yeah.
that Prima India is so in US, Native Americans or the tribal people are called Indians.
Acha, acha.
Yeah,
Okay. Thanks for
yeah.
adding
So
that.
they're not from country India, but they are
They
from.
called it as Indians, huh? I mean,
Yeah, exactly,
whoever.
correct. So
Okay.
so before European colonization happened in America, they were like native people to the North America.
Okay.
They were
Okay.
tribes,
That's
different
why they
tribes.
called us Native Indian, Native American
Yeah.
group. Okay. Cool.
So Pima, yeah, there were like 20 different group of in different type of Indians, and
Hmm.
Pima is one among them, I guess.
Okay. Similar type of thing also happened in India also. In India, one tribal, tribal diabetes, diabetes data set in India for machine learning. So same type of research also happened in India. One of the tribals, I don't know whether they recorded it, data set. Uh,
So if correct me anyone if I'm wrong.
yeah, you may be right. Like because the name is having India means I thought of maybe origin. I don't know this background story. Now I am getting this Native Indian, Native American group living in Arizona and Mexico. Okay, and mm, what I feel is South America also Indians who migrated a long back. Some story happened. I saw in one documentation. Maybe that was the reason I misguided. Okay, fine. So whatever. So this is a data set being collected, and they identified that the diabetes and all. The more like maybe environment parameter. I don't know. So they identified they wanted to do research on the diabetes. So these are the column names. Sometimes if you don't have column names, okay, if you don't have any column name here, see here you can see there are no column names. But those column names were if your stakeholder or if your business person, mentioned you separately. Like first column is pregnancies, second column is glucose, third column is blood pressure, fourth column is skin thickness, insulin, BMI. These are the diabetes pedigree function, age, outcome. These are the column names. If you know, then you can add them as names. Okay, along with the data set reading, so that the data set definitely will be read the data as it is, along with the names whatever you are passing to it. Okay, so this data set again, I already explained how to upload and then copy the path and then passed it here. Then df.info, how to do the basic information and also find out if there is any null values or not. Actually, there are no null values. If you see the original data set, it will have null values and also a lot of pre-processing can be done. But this data set, no null values. Instead, they actually replaced with zeros. You can see zero, zero, zero. Some of the sources in some of the sources you may see null value as zero. But this data set, when we talk about this data set don't have any null values. But if you observe, okay, Mushraf is joining. Okay. If you observe this data set particularly, it is having some values. Okay. So those who are interested into medical data set or as a healthcare data set, you observe that, insulin value 000. Is there any wrong or it is okay? You please tell me if a person is having zero insulin. Is it possible? A person is having zero insulin.
No.
No, right? So, so sometimes, your data set may have values like this. Then why zero? When the people who are collecting the data may don't know about the insulin value of this particular person, so that's why they might have replaced with the zero. Okay. So such situations, you have to understand the domain. That is why domain knowledge is very important. If you know the domain knowledge, then you identify such values. Then you might have replace or else remove, or you can do some other operation. Okay. So now what we are doing is we are not going to go in that perspective. If you are interested, you can solve that effectively using the domain knowledge. Okay, how to replace zero with an effective insulin value of the person, maybe based on glucose value or blood pressure, skin thickness, BMI. Is there any way to calculate insulin out of these factors? If yes means go and find out and then calculate. If not means is there any way to replace it with median or mean? Is that okay to provide more data to the current data set? Those are also can be considered as feature engineering. Okay. So now what are the steps what I did is here I can identify that there are no null values are there. So I willingly, so in order to show you like this step, okay, in order to show you as a step, willingly what I'm performing is some columns 5 to 15 rows of glucose, fifth row to 15th row of glucose column. I am replacing the values with null value so that I can have some null values. Here you can see initially the data set is not having any null values, but the first step of feature engineering is you have to know how to handle the missing values. Okay, so that is why I'm considering and introducing and creating some missing values. Okay, here you can see glucose level. Now we are having 757 only. That means there are some null values. How many? There are total 11 null values are there in glucose. We only added. If you find any null value, a column with null values, then how to deal? That is what the concept I'm covering now. So how to deal that concept? How to deal means there are two standard ways. First way is can be dropping the null values. I already explained you in pandas. And the second thing is to in place. I mean to impute the null value by mean or median, mode, or replace with any standard suitable data point. These are the two standard ways. And there are some other ways also. That is what today's session we are going to learn. First thing is interpolation. Interpolation. Interpolation is something like we will estimate, we will estimate what can be the missing value. We will estimate that and then we will fill the null value. So we can have two different ways. One is interpolation. Interpolation is something like can be done either linear interpolation or polynomial interpolation. The second step is k nearest neighbors. Okay, so I might have write like this, then it will be very clear to you. Hmm, 1, 2, 3, 4, 5. Yeah, here you can see first thing is interpolation. Other than the dropping null values and other than replace with a standard value, we can also do interpolation. Interpolation means there are two ways again, linear interpolation and polynomial interpolation. Okay, let me show you what is that linear interpolation, how it looks. Okay, so Wikipedia. Here you can see if you have 2 points x0 y0 and x1 y1. So based on these 2 points, if it is passing the if it is following the if it is following the linear trend, okay, if the trend is linear, if the data points are linear, then we can use linear interpolation. We will estimate a point between these two and then we will replace the null value with that, so that it will follow the same path. I mean it will follow the same strategy, and this is one of the best ways. When we can use linear interpolation, remember, identify the plot. Here you can see this is the glucose that I just plotted. Here it is not linear, but whenever you identify linear, then only you perform linear interpolation. If you identify any, okay, if you identify any polynomial, then go for polynomial interpolation. Okay, polynomial interpolation. In polynomial interpolation, how it will be like it will be a curve. Okay, polynomial way. You know, right? Yeah, yeah. This is the polynomial. If your trend is linear, then go for linear interpolation. If your trend is polynomial, then go for polynomial. You can go through this theorem and how it works and explanations and all. Okay. But when it comes to our use case, we don't have a trend of linear or polynomial. We have like zigzag, noisy trend. So in this situation, how we can do is we can go for k nearest neighbor imputation. K nearest neighbor means simply the data points around some, for example, so this is what the trend irregular. So this point, this point, we will take the some group. Okay. So we will take some group k nearest neighbors. K stands for a scalar. Any number, let us say it can be 3 or 5 or 7, any number. We will take one number, let us say 5. So 5 nearest points are there, right? We will take 5 nearest points and then we will take one mathematical operation on that. For example, here you can see we are using k nearest 5 things we are doing, and then nearer to that 5 points. So we will do either average or something like that, and then we will impute that value with this. Okay, let me show you that track. KNN imputation. Imputer. Is there any Wikipedia? No. Then we can go for official documentation site. Okay, so it will helpful in for machine learning. So by default, 5 neighbors will be considered, and uniform weights will be given. Euclidean, okay, non-Euclidean distance can be calculated, and this is the all the remaining functions which are available with this, and it will you can see imputation for complex missing data. Each sample missing data are imputed with the mean value. Mean, here you can see mean. Okay, we will find the average of those near 5 values and then calculate that average and then impute that value wherever null value it is it clear? So how to deal null values or missing values in reality, is it clear? The best
Yes.
practice. Yeah, good. So you have to identify whether you can go for dropping the null value or else impute by mean or median of that entire column, or else you can also do these two steps interpolation. One is linear here if you change linear with polynomial, then that is a code you can use for polynomial interpolation. But anyway, you have to check whether the trend is having any linear or polynomial. If it is yes, then go for linear or polynomial interpolation. Otherwise you can go for KNN imputation. Okay, simply you can mention 5 or 6, whatever the number you felt it will be good to fit. Okay, then second concept is
So,
handling the, yeah, please.
uh, yes, which one will give the more accurate uh, result? Like,
Which one means interpolation or KNN implementation? Huh?
yes.
Yeah, see here, it is a way, for example, here you can see null values are with glucose. I just plotted the null values, how exactly it is. The trend is not linear, not interpolation. Then definitely it is for sure go for KNN. Okay, or any other imputation like mean or median or mode replacement. And very good question, which will give us the best accuracy? See, first of all, data science is always kind of an iterative process. Iterative process means we will first consider one strategy, we will do that, we will test the accuracy and all. If we feel that accuracy is not good and not making any sense, then we will come back to the pre-processing step. I mean, this feature engineering step, do some more feature engineering and do work on it very well, and then go for again. So that is why this picture. Yesterday I told, if we did not get any accuracy, desired accuracy here, then again this step has to be performed again. The feature engineering again, change the features, change the algorithm. Okay, do it in other way, something like that. Clear? But
Okay, yeah,
usually
got
this
it.
is a strategy. Usually this is a strategy. K nearest neighbor will gives us again. Again here you may have a doubt. So why 5? Why not 3? Why not 2? Why not 1? Why not 6? So it is also can be iterative. You can check with 5. By default it is 5. So identify the null values with the other values. If they are very close to the things, then go for 5. Okay. And one more way is there, one more way, obviously domain knowledge. According to the domain knowledge, if we know the domain knowledge, then glucose is the column, right? What we are handling. For example, if any person is a diabetic, okay, what are the glucose values? And check the glucose value with diabetes, check glucose value with not diabetes, and check whether we have null values with respect to diabetes or not. If yes means what are the glucose values of others who are having these features. For example, null values are there when pregnancies are less than 3, and blood pressure is so and so, skin thickness is so and so, EMI is so and so, sorry, that BMI is so and so, insulin is so and so, DPF means diabetes pedigree function is so and so, age is so and so. So identify our imputed value, where we exactly imputing, na? Identify the imputed value with the real value, then cross verify. If, is it possible to have this value? For example, here you can see insulin, according to the data set, here it is 0, but it is actually not possible. So it might be an error, a typing error, or else not known information, means maybe null value. That's why they replaced as 0. Okay, so you have to cross verify with the outcome with the existing value, and cross verify which is really good, which is really matching. Got it? So with five neighbors, you check with the value. With three neighbors, you check with the value. Which value is more making sense? Then you can consider that. Is that clear?
Yes,
Prajwal and
yes,
others.
Ashwin, got it.
Yeah, good, good.
Thank you. Are
Yeah, yeah,
we recording this session?
yeah, yeah. We are recording this session.
Thank you.
Okay. Handling the categorical data. First of all, what are categorical data? If you identify any column is having some categories or a text, is keep on something like I can say it in one line that uh, the discrete values in terms of text, the discrete values in terms of text, here you can see the discrete values USA, Japan, Europe are discrete values, but they are actually text. Okay, so those are categorical value. Again, in categorical there are actually three terms. In statistics you might have learned that three ways: ordinal, nominal. Okay, these are the ways: ordinal, nominal, and order, nominal, and what are the other? Ordinal, nominal, and ratio. Okay, or interval. Okay, sometimes these are the three ways. Like categorical data can be ordinal, nominal, based on ranking, based on if there is any order, that is ordinal, otherwise nominal. We call it as in statistics. Simply these are the text, but into text, like categories into text. That is what categorical data. Here we can see there are three ways to do to convert that into numerical, because we know that in machine learning or any other scientific. Just a second, I'm getting a call. Just a second. Hello. Okay. Hello. అవునా, మీ మామ అంటే ఎవరన్నా? ఓకే, ఓకే, అదేలేండి. ఆ, నేను ఏ విషయం మీకు కొంచెం ఎప్పుడైనా కనుక్కొని చెప్తాను. ఓకే, బయట ఉన్నాను నేను. రేపు చెప్తాను. అప్పుడు ఎప్పుడో హాస్టల్లో ఉంది మాది, కనుక్కుంటారా నాకు ఇప్పుడు ఫోన్ చేశాను. Yeah, so I'm back. Yeah, we are going to handle, I mean, we are going to know, so how to handle such things. Okay, because in machine learning or in general also, computer don't know or cannot understand the text data. So we have to convert them back to the numericals, right? So for example, this origin and all, origin is in USA, Japan, or Europe. So we have to convert them to effective numericals like this. Here you can see these are all numericals. This also has to be converted to numericals. How to do that? So in order to, do that, first of all, we have to have a column with categorical data. But here in our data set, if you see, this is the head of the data set. We don't have any categories with respect to our data set, right? So that's why, in order to explain this concept, I am creating a new column of category randomly I'm assigning the values as either A or B or C. So this randomness is cannot impact the entire data set, because this is doesn't making any sense, right? So we are adding C means category one, C means outcome one. Also don't have any. But in order to explain you as a concept, for example, if you have any category column, okay, which are either nominal or binomial, sorry, either binary or nominal, ordinal. The third one is binary actually. Now I remembered. Yeah. Binary, nominal, ordinal. Binary means only two values if you have. Like in a gender column, we will always have male and female, right? And also pass or fail, grade, right? Only two values only keep on repeated in terms of text. That is what binary. The second thing is ordinal. Ordinal means some order will be there, like small, high, small, medium, high. There is an order. Small is small thing. High means some range will be there, and medium means between range will be there. If there is any order is assigned to the value, then it is called ordinal. Then nominal means if it is not binary, if it is not ordinal, then we can call it as nominal. Okay, is that clear? There are three things. Okay. So let us consider one nominal. So where A, B, C don't have any order. So and it is also not binary. So it is nominal. Three ABC values randomly it assigned entire data set. Okay. So now our new data set is having these values. Pregnancies column, so glucose column, and blood pressure and all these are columns. Along with that, the new column also assigned. Here we can see some text data. Simply these are all categorical data. So using these three steps, how to solve this? First one is one hot encoding. First step is one hot encoding. One hot encoding is simply you can see how many categories we have: A, B, C, right? So you will have that many columns. Category A will have one column, category B having one column, category C will have one column. You observe this one, this explanation. Three columns we have: A, B, C. Then three different columns automatically will get added to the existing data set: A, B, C. According to the category column, the first value is, so these are the data points. Let us say five data points are there, and category column A, C, B, A, C. These are the values of the categories. Now it is A means A have 0, 1, sorry 1, B has 0, C will have 0. This is completed. C means C only will have 1, remaining will be 0. Okay. Then B means only B will have 1, remaining will have 0. Again A, 0, 0. C, 1, 0, 0, 1. Is this clear how one hot encoding works? How one hot encoding works? Is that clear? Is that clear? You observe now. First category is C. Then it will have 0, 0, 1. Is that clear? Can I get a quick confirmation? Is that clear? Okay, I'm not seeing yours.
Yes, so C will have 0 at the end.
C will have 1 at the end. 1.
Yeah, sorry, 1 at the end,
Yeah.
correct.
And what I'm doing an extra thing is here, if you see, I'm dropping the first column because because to save the columns size. If you have three columns or any number of columns, first column is not that much important, because if C value, B value both are 0, that determines obviously it is A, right? Is that making sense?
Yes, it
Correct. That is
makes.
why first column or last column, any of these two things, three columns are not required. One column we can drop, because if we are dropping first column means if both values are 0, obviously it is telling us it may be A. Got it? It should be A. Then only the two other values are 0. If not means they will have assigned with 1, right? That is why. So one hot encoding is nothing but we are going to add extra columns to the existing data set based on their category values. If categories are only three, then three different columns will get added. Of course, we are dropping the first one, so two will get added. For example, if this column is having 10 different categories, see, observe this, our data set, cylinders are there, right? How many, uh, how many unique values we have? How many? We have one, two, three, four, five are there. If there is any column where instead of eight numerical, if we have EIGHT, instead of 8, if we have like this, then this is also considered as a categorical column. We have to do some feature engineering here. We have to convert that categories to numerical. So in order to do that, we have how many such things? One, two, three, four, five different things. Okay. So five different things means we have to, if we consider one hot encoding, then five different columns will get added. Is that clear? Five different things will get added means data size will be large. Correct? So that is why we have to think whether it is required or not. If you feel like less number of things are there, if we increase the data set, maybe more number of features going to give the machine learning, then it will help us to make our machine to learn in a better way. Then go for one hot encoding. Otherwise, we have other two different things. One is label encoding. Label means label means instead of creating a new columns, the same column category, the same column according to the rank means number of times it been repeated. Okay, for example, A repeated more, then rank will be 0, like that. B repeated more, rank will be 1. C repeated less, then rank will be 2. Something like that. According to the rank, the category value automatically will get replaced with 0 and 1, 2, 3, something like that. No matter how many unique categories are there, that many number it will go count and replace. That is what label going to encode. Last thing is called target encoding. If you specifically want A should be 1, B should be 2, C should be 3, you can mention the target and then you can replace it. Or else if you want any mean, okay, calculate the how many A's are there, group by it according to A, and then calculate the mean and then replace A with that mean. These are all target. In what way you want to replace that A with numerical value, either by grouping and then transforming to mean or something else, or else if you specifically want A should be 0, B should be 1, C should be 2, irrespective of its rank. Because label encoding by default rank is what applying. And here uh, target encoding means we have to specify the target and then we can impute that. Is that clear? These three things, handling the categorical data, how to handle the categorical data, is that clear? There are three ways. Is all three ways clear?
Can you go to once again, please?
Okay. So whenever you have any column is having categories, means a text data in unique, okay, uniquely distributed. That is called categorical data. Is that clear? What exactly categorical data? Is that clear?
Yes.
When we call the data
Yes.
as categorical. Okay. So if you have such a categorical data, you have to convert that into numerical, because computer cannot understand, even machine learning algorithms also cannot understand if there is any data point is text. We have to convert them to numbers. In order to do that, there are three ways. One way is one hot encoding. Second way is label encoding. Third way is target based encoding. One hot encoding means how many unique values are there, those many columns will get added to the existing data set. Second, okay, second step is label encoding. Label encoding means by default it uses the rank concept according to the number of times. For example, in this data set, USA being repeated largely. I mean USA being repeated a lot of times. Then USA will be assigned with 0 automatically. We are not going to do manually. Automatically it will assign like that. Okay. and that is what label encoding. Third thing is target based. Target based means we want to specify what to replace. For example, if you want to replace USA with a fixed number, then you can do that in target based encoding. What is your goal? Accordingly, you can choose any one of these three. Is it clear now?
Yes, it is clear, Yashwant. Thank you.
Yeah, I got it.
So we can
So,
use
yeah, yeah,
three
please.
in any of these three,
Which
depending
is
upon our requirement.
which is greater, which is better. So basically, I suggest if there are only two, if there are only two values like gender, male and female, there are only two values. In that situation, you can go for one hot encoding because two columns only will get added. Out of that, again, we can use this function called drop, right? Drop first, so that only one column will get added. For example, there are only two things. Observe this one. In a column, there are only two values are there: male, female, 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 male, something like this. The data points are there. There are two unique values means two different columns will get added, right? So one column for male, one column for female. If it is male, then the data points like this: 0, 1, 0, 0, 1, 0, 1, 0, 1, 1, 0. Then if we are dropping the first thing, then only one value, one column only will be there. 0 stands for female, 1 stands for male. Is that clear? Sorry, 0 stands for male, 1 stands for female. Is that clear? So if you have only two or limited number of unique values, then you can go for one hot encoding, and that too if your overall data set is small. Here we are only having 1, 2, 3, 4, 5, 6, 7, 8, 9 columns only. It is okay to have uh, 10 or 11. Still the data columns, number of columns are less. Less means okay, some fixed number like 11 is okay. It will take less time. So time is also important, right? Time factor is also important when we are building algorithms, right? Space complexity, time complexity. So we are not going to think in that complexity, but at least in a general sense, if there are more number of features, definitely it will take more time to build a machine learning model. If you have less number of features, it will take less time to I mean, to make our machine to learn quickly. So that is why if your data set is small enough, then if you also have limited number of categories or unique values, you can use one hot encoding. Got it?
Yes, got it.
Yeah. Then why when label encoding can be used? Listen, when label encoding can be the best thing, if there are more number of categories are there, like let us say three, four, like that, and also if you don't know if you don't have any specific value to target, then you can go for label encoding. Automatically, machine will assign according to the rank system. It will assign the numbers. Okay. So in some situations, some domains, okay, definitely domain experts will tell replace this value with this, then target encoding. Okay. We can say, for example, we can say best example I will give you ONE1 TWO2 array filling TWO2. Let me take three values: 3 EIGHT 8 NINE 9. Is there any column which is having this way? Okay, the data got arranged like this. Here I cannot use label encoding. I cannot make my machine to assign some 0 to here, 1 to here, 2 to here. I cannot assign like this. I have to go for target encoding. Where there is 1, I have to type, I mean, I have to literally convert according to the number. Okay, I have to target it. Is it clear when target encoding is useful? Is it clear? when we can go for target encoding, and when
Yes.
we can go for label encoding. For example, origin, Europe and all. Here, I don't have any specific reason to tell or USA means some value. Here I can go for USA means 0, Japan means 1, Europe means 2. According to the ranking system, I will leave it to the machine automatically complete those. Then label encoding. Here, if anything like this, then I only have to go for target encoding. Okay, I have to mention a target as a format of dictionary. Okay, you can choose one dictionary. Okay, so target dictionary. So you can choose like this. So one where there is one, then you can like this replaced value PWO2 2. Then you can iterate with the entire column and you can replace where exactly one is. Then you can replace with any specific target. This is how it works. Target encoding. Here we don't have such. Instead, what we are using is we are grouping according to the category, and then we are just a target with their mean value. Is that clear? How these three works and when we can go for what strategy? Is that clear? Is that clear? These two steps
Yes.
and
Thank
yeah,
you.
good. Okay, the third step is feature scaling. Then, what is feature scaling, and also we will learn what are the different ways and how to do it. Feature scaling is sometimes we have to scale the features for better, way to learn the machine. Okay, for example, if the values are just arranged like that, sometimes it is important to scale them, the continuous values. Uh, so in order to do that, I will tell you. So what is this feature scaling and what are the best practices also I will tell. But before that, just understand scaling means we will convert every value between the specific ranges. For example, min-max scaling. This is useful for normalization. There are two techniques, normalization and standardization. Normalization is nothing but we are going to normalize all the values of a specific column between 0 and 1. For example, this column, I wanted to normalize the displacement values. Then, instead of 307, 350, 318, instead of that, I wanted to convert all the values between 0 and 1. 0 and 1 only. Okay, why this step has to be taken? I will explain bit later. But before that, just understand min max scalar means specifically 0 and 1. We will scale down all the values. This step is also called as normalization. Then the second step is standardization. Standardization is the second step, which is always works on the center features around mean. We already learned yesterday in statistical inference. We learned about standard normal distribution, where mean we are going to equate to 0 and the standard deviation we are going to equate to 1, right? So same strategy. So that is what standardization. So just understand the coding in what way we can do. So min-max scalar anyway we introduced along with the scikit-learn pre-processing step. Here pre-processing we introduced min-max scalar and standard scalar. Understand the coding. Then I will explain very clearly why this is important, in what way we can do it better for the better practice. Okay, min-max scalar, just call that object and then use this function called fit transform and mention what column exactly you want to change. Here I wanted to change the glucose value. So that's why you have to literally provide the data set. So not only one column specifically, maybe if you want to do this feature scaling, 2 to 3 different columns, you mention all the columns or to do this feature scaling. Like here, I'm only doing as a part of explanation. Here, I'm only doing the glucose column only. But if you want blood pressure also, skin thickness also, you can create all such columns like this. I am creating one more column here. You can see glucose min max along with the existing data set, just to explain you fit transform. You can use that as a function inside min max color to automatically convert. Here, if you see the values, all the values are between 0 and 1 only. There is no value above 1, below 0. Okay. So second step is a standard scalar. Standard scalar also you have to call the object, and you can use this function called fit transform. And this what it will do is it will make every value to center around the mean. Then mean will be 0. If you calculate the mean will be 0 and standard deviation will be 1. We will do that and then center around that feature. Okay, now let us understand when to use this min max scaling, when to use this standardization. I have created that. I know that you may ask that question. That's why I created notes for you. Here you can see choosing the between min max scaling and standardization. Min max scaling I already told, right? Normalization. Between normalization and standardization, when to go for is basically this technique will help to scale down the data to a fixed range. Okay, fixed range. Sometimes it is important to scale down our data to fixed range. For example, height is there, weight is there of a person. Okay, we are having a data set of individuals like height, weight, something like that. Let us consider that example. In that example, if in the column it is very clearly say like height is measured in centimeters or height is measured in meters, it is okay, conveyable. But if they did not mention height is measured in what particular unit, definitely it will be a big difference. 160 centimeters versus 5.6 height, there is a lot of difference is there, right, in terms of units. Similarly, weight, kgs can be calculated weight, and grams also can be calculated. And there is a big difference between 5,000 grams and 5,000 kgs, right? So in the data set, if it is not very clear that in what unit they actually collected, then it is a better that to arrange all the data points between some range, okay, to help the machine to understand, okay, all the data points are in this range. Then it will be helpful to the machine to understand in a better way, to come up with a pattern in a better way. Okay, and that is the reason. So we can do that scaling. Sometimes it is helpful. um, so there are two ways: normalization and standardization. Normalization, when to go for normalization means if you identify the data is does not following any normal distribution. Yesterday I showed you what is normal distribution, what is skewness. If your data set is not having any normal distribution or Gaussian distribution, then min-max scaling is the best thing. According to the rule of thumb, the algorithm you are using does not assume any distribution of the data, then you want to maintain the relationship between the original data points, then go for min-max. Okay, however, min-max scaling is sensitive to outliers, so they can again significantly affect the scaling. So that is why whenever it is sensitive to outliers, you have to effectively deal. You have to identify whether they are sent outliers or not. If not, if yes means it is sensitive, so you have to handle them and then apply. That will be the good practice. Second, standardization. When to go for standardization means this method will have the mean 0 and standard deviation of 1. This is good when the data follows a Gaussian distribution, and also algorithm assumes the data is centered around mean. And whenever you want to reduce the impact of outliers, okay, you want to reduce the impact of outliers, as standardization is less sensitive. Here you can see standardization is less sensitive towards outlier compared to min-max scaling. So that is where you can use standardization, and particularly beneficial algorithms, something like if you are using support vector machine or principal component analysis. These are machine learning algorithms anyway. I will teach you later in the coming days. So if you are using those algorithms, standardization is the best approach according to the rule of thumb. Okay, rule of thumb means it is a best practice. Okay, it is a rule of thumb means it is a best practice out of what we have. Minimum min max scaling, this is the best practice when you can go for, I mean, identify the data whether it is Gaussian or normal. Then if it is Gaussian, then go for like that. Let us see what our data set is, because glucose is the one we used, right? Then let me draw glucose plt. First of all, let me run the before cells, because it will throw me an error if I don't run the before previous cells. Control X, I will include the same library in the library sections only, and rerun this. And now anyway data is there, info is there, isna is there, plt is there. Okay, let me run this, let me run this, and head, also encoded head. feature scaling. Yeah, now PLT dot histogram is what will help me to plot the glucose. Okay, here you can see the data set is somewhat normal. Like it is, like if we go and plot the seaborn, then we will get clearly import seaborn as SNS, then SNS dot hist. Yeah. Now if you see where you can also include KD parameter equal to true. There you go. So it is, it is not perfectly the standard deviation, sorry, normal distribution, but very close to the normal distribution, right? Very close. Are you all agree with me? Very close to the normal distribution. So if it is very close to the normal distribution, then it is then standardization is what helpful for us. Okay. Otherwise, go and apply min max color and again check whether there are null values are there. That is why the function in pandas like def dot describe really helpful. Okay, in especially glucose, if you see the minimum value is 0, the 25% is 99, and mean is 120. Median is also close to 120. See here you can see 120 and 117. That means whenever mean equal to median, I told you yesterday, it is a normal distribution. That is why we can go for standard normal distribution. I mean standardization process. When there are when these two are equal, that is called normal distribution. It is distributed in normally. Then we can go for standardization process. Okay. Uh, and outliers. If you see outliers, it may have outliers. You can check whether outliers or not. Also using box plot. PLT dot box plot of box plot of glucose. Okay, very less outliers. Zero is the outlier. Obviously, glucose, no one is having glucose as zero, similar to insulin. We have to remove those actually. We can remove that. According to the domain, you can identify who is having zero glucose and zero insulin. You can later on do that. Okay, because it respect to the domain, not in general. Now, whatever concepts I am teaching you, those are all in general. Okay, and also with respect to the domain, again, this will get changed. I already mentioned many times. Okay, so here you can see there are no upper outliers, especially. The data is very well organized without having any outliers. Though we have outliers, still standardization is good because it is less sensitive towards outliers. And if there are more number of outliers, and if you really wanted to scale down between 0 and 1, and also the data is not normally distributed, then go for min max scalar. Is that clear, everybody? So when to go for min max and when to go for standardization? Min max is also called normalization. When to go for normalization, when to go for standardization. Is that clear? Can I get a quick confirmation?
Yes, Yash.
Very good, very good. Then we can learn the next concept, which is about creating the polynomial features. Okay. Sometimes it is, I already mentioned, sometimes it is important to create some extra features. Okay. Along with the current data. Say if you identified that according to your domain and according to the problem statement, data points or features has to be created. Then you can use this as a concept, polynomial features. Simply what we will do is generate new features by just raising an existing features only to the powers. Okay, polynomial means it will have the degree, right? We are just you making use of that degree function. Here you can see degree 2 and to raising that parameter so that and also creating some interactions between the features, and it will allow models to capture non-linear relationships also. If you identify your data set is having non-linear, then polynomial feature creation may helps. Okay, for that what I'm doing is simply I'm just using imputer again imputer again to consider 2 points, BMI and glucose. Both values I am going to replace the null values with imputation. After imputation, polynomial features. This is the way how to use the polynomial function, and mention what degree that you want, degree power 3 or power 4. Polynomial is simply, right, x square plus y plus 1. This is simple polynomial with degree 2, x cube plus y square plus 2, 2x, something like that. Then highest degree is 3, then that is what, degree with 3. So in that way we raise the power so that to create a polynomial thing, and then we just use fit transform again and create a new data set. See, this is a new data set which are also having the polynomial BMI square and glucose square. Okay, sometimes adding new features also important. It is according to the domain knowledge and according to the use case, but not applicable to in every project or every thing. But if you have any such situations or any, you can use this as a concept. And then feature selection, how to do the feature selection. Then feature selection is a very crucial, machine learning, that involves identifying and retraining the most relevant features. What are very relevant features are important. So in order to do that, we can have two steps. One is univariate feature selection. Second one is L1 regularization. Univariate is something like it selects features based on statistical tests. Yesterday we learned about some statistical tests, right? T-test, Z-test, ANOVA. All such are statistical tests comparing T-test, okay, comparing two mean and comparing proportions. Okay, we yesterday we learned about that. Univariate feature selection is simply it will use that statistical test and retaining those with significant relationships to the target variable. It will compare with the target variable and it will do automatically, and then it will select the best features. L1 regression is simply like it is adding a penalty to the model. Anyway, this regularization concept will come in linear regression. There we can discuss more, but this, before that, just have an idea. This is a penalty adding. In order to do that, so we will have large coefficients so that effectively shrinking some coefficients to the zeros and performs a feature selection. So these are the two steps. Univariate selection you can understand here, but anyway, L1 regularization, if you don't understand here, don't worry. We will again discuss this concept in machine learning concept of regression. Okay, their regularization of regression models is a concept is there. There L0 regularization, L1 regularization, L2 regularization, we will discuss there. It will come as a part of again polynomial regression. Yeah. Okay. So feature selection, we understand how univariate feature selection happens. Univariate selection means just use the selected d types, data types where number, it applicable only number column. Okay. That is why obviously we already anyway converted all the relevant features into numbers, right? Even category also we converted into the numbers either by label or else we used different ways like uh, three ways, right? Category encoded, target encoded, label encoding, and one hot encoding. Any one way is enough, okay? Not three ways should be implemented, any one way. I already told which way is better in what particular situations. Okay, so you can choose one strategy and you can implement. And by the way, you have to only select the columns which are having the D type as number. Excuse me. Okay. So before again going to do some univariate feature selection, first of all, make sure that your data set is not having any null values. You have to impute them. Here again, for the safer side, I'm using KNN imputer with 5 neighbors. I'm just imputing to the again numerical data set. Then comes to the selector. Select k best is what the function, it is again assigned along with the, it came along with the pre-processing yesterday. Sorry, not yesterday. In the beginning of the session, I told in the import statements. Here in import, we have seen this. No, no, no. Feature selection is what the section. Feature selection, there are two things: F classify and then select k best. This lasso comes under linear model. That is why linear regression we can discuss this lasso more. Here feature selection we use select k best. Select k best is something like We use it for univariate feature selection. Here you can see that particular function you can use, and you can use the function score function as f classic. And again, k is equal to 5 means you can specify a scalar value, how many number it is you want to select. Then you fit transform again, drop the output column, because this is the this output column is what the uh, you know like that sorry, machine learning, once I start machine learning, then you will understand this concept, why we are dropping the output column. Anyway, I will explain that concept very short time. But understand, feature selection is always nothing but, let me tell you in this way so that you will understand. Feature selection means there are two types of features. One is input features. The second is output feature. Output feature is always, obviously, in supervised machine learning algorithm, we will only have one output feature all the time. Okay, so input features can be more than one, or one or more than one. Okay, definitely not zero. So one or more than one input features will be there. One output feature should be there in supervised machine learning algorithm. In this situation, output feature always will be one, right? We already know that it is an output feature. That is why we are dropping that. Don't confuse. Instead, in input features, we can have many input features. Out of many, we have to select the best ones. For example, let me show you this particular thing. Let us consider there is a column called price. Okay, here it will explain you all the prices of the cars. Okay, all the prices of the cars. We wanted to predict the price of the car based on these values. Let us say this is the use case. So you know that this is an output column, but input columns, these are all input columns. You wanted to know that out of these many input columns, which input columns are very important. You have to select. That is why we are dropping this thing, and we are left with this, and that too only numerical. We especially mentioned that numerical is what we want. Here you can see numerical is what we want, and then dropping that, and then selecting. So that at the end you can see numerical df. If you run, these are the columns are really important, it is saying. These are all columns are, they consider, because univariate feature analysis means it is considering with the statistical tests. It will take the statistical test, and by default, in the back end, all the statistical test it will consider, and then it will come up with with respect to the output column, what are the columns are really important. It will come and will